Hello, this is Pravina, and today we are going to study about the Pythagoras theorem. So it is a theorem which relates the sides of a triangle, and it is a special triangle that we can say that it is a right angle triangle. So okay, first we will understand what a right triangle is. Right angle triangle is. So it is a right angled triangle. So as the name says, it is right angle triangle. So right angle is the angle which is equals to 90 degree. Okay. So whenever we draw a triangle, like let us say that this is the triangle, and in this triangle, we can easily identify that this triangle, if we name it P, Q, and R. So this angle Q, it is of 90 degree, and this defines that this triangle PQR is a right angle triangle. Okay, and now the most important thing is this property is related to only the right angle triangle, and it can be in any of the orientation. Like if I have drawn the triangle like this, and this can be drawn in different shapes. Like you can see, it can be drawn in this form. And if I name it triangle A, B, C, then this triangle is right angle triangle, which is right angled at B. Okay, then if we see other triangle, then it is now it is just the rotated form of that previous triangle, and now we can easily identify that this angle is 90 degree angle, and this triangle will also be a right angle triangle. Then if we see this triangle, okay, this is done. Yeah, this one. Now we can see it would be hard to imagine that this angle is 90 degree, but yes, we can easily identify it also. We can simply rotate the notebook or the page, and then we can simply find out that this angle is 90 degree. So this angle is also going to be a right angle triangle. Then we can move on to the next one. Yeah, here it is. It is just the inverted form. Then again, we can say that this angle will also be a 90 degree angle, and this is also a right angle triangle. It can be drawn in any of the orientation, so it doesn't matter that how it is drawn. It will always be a right angle triangle. Like you can see that this is also a right angle triangle, and all we need is just identify the angle which is 90 degree, and we can name it in any of the form. From any side you can write the names in clockwise or counterclockwise. Like if I want to write it in counterclockwise, it will be x, y, z. Then we can say the triangle x, y, z is a right triangle. Or if we want to write it in the clockwise form, then we can simply write it as x, z, y is right triangle. So it doesn't matter how we write the name. The sequence must be correct, and however we write it, the sequence will always be the correct one. Okay, then you can say that it is also a right angle triangle. This is 90 degree angle. It will be a right angle triangle. Then we will relate to the properties of these right angle triangles. Okay, so now we will move on to the concept which is related to Pythagoras theorem. Okay, let's see what is it. Pythagoras theorem. So we will consider the simplest form. Like if it is the right angle triangle and it is named as PQR. So of these three sides, it is quite obvious that the side which is in front of the greatest angle, which is the 90 degree angle, that will be the longest side. So Pythagoras theorem says that the square of the longest side, that is PR square, will be equal to sum of square of the other two sides. That will be PQ square and QR square. And we can also name them. Like if you want to name them, then the longest side will be the hypotenuse. It will always be the same. Hypotenuse. Then this will be the base, and this will be called the perpendicular. And if I draw the triangle like this, so it doesn't matter like if it is 90 degree angle. So the side which is in front of the 90-degree angle, that will always be the hypotenuse. Then we can consider any of the side as base, like we can consider this as base, and this side we can consider it as perpendicular. So now, if we want to write it in the form of the terms related to the right angle triangle, then what it will be? The square of the hypotenuse will be equal to sum of the square of base and perpendicular. And we can find out the values of any of the sides by using this property, and it will always be the correct one. So let's take an easy example for this. Okay, let me draw a right angle triangle. Like this is a right angle triangle, let us say. And in this triangle, one side is given 3 centimeters and this side is given 4 centimeter. Let me name it as X, Y, and Z. And this angle will obviously be 90-degree angle. Then what we are going to do is we will simply now Pythagoras theorem says square of the hypotenuse will be equals to square of perpendicular added to square of the base. So in this case, or you can simply consider these two sides, perpendicular and base, as the sides which are not the hypotenuse. The sides other than hypotenuse, we will square them and then add them. It will be equal to the square of the hypotenuse. So now, hypotenuse will be equal to xz. So now we will write it in terms of the right angle triangle, that is xz square will be equal to, then we can consider any of the side as perpendicular. As we consider this one as perpendicular, so it will be xy square plus yz square. Now we can simply put the values of the given sides, like xy is equals to 3, we will square it. Then it is yz, we will square it again, square of 4, that will be equal to square of xz. Now we will solve it. Square of 9, that is square of 3, that is 9. Square of 4, that is 16. It is equals to square of xz. Then when we will add it, it will be equals to 25. The square of xz is equals to 25. Then we want to find the value of xz. So what we will do? We will find the value of xz, which will be equals to square root of 25. We can write it here, taking the square root on both sides. Now, if we want to find the square root, it is quite easy. That square root of 5 will be equals to 5 into 5. So square root of 5 will be equals to 5. That is why we will say that xz will be equals to 5 centimeter. This is the most basic, easiest form. And in this way, we will find out that the length of the hypotenuse will be equals to 5 centimeters. Okay, let's take another example. And now we will consider other side which is missing. Like if it is a right angle triangle like this angle is 90-degree, and let us name it as P, Q, R. And let's say that this side is 13 centimeters and this side is 5 centimeter, and we don't know what will be the length of QR. Okay, so these two sides. Now, it will be confusing that which side we should consider as perpendicular or the base. So we can take it as random, that this is perpendicular and this is base. But the side which is in front of 90-degree angle, that will always be the hypotenuse. So now again, following the Pythagoras theorem, it will be x square is equals to p square plus p square. Then hypotenuse h is 13. So we will square 13, which is equals to, we have considered p as 5 centimeter. So it will be square of 5 and then b square. We will now calculate a square of 13, that will be 169, which is equals to, now square of 5, that will be 25 and plus b square. So now, in this case, whenever there is a situation, either we are solving algebraic equation or we are solving Pythagoras theorem or any other thing, the only concept that works out here is we will just move the numbers one side, and all the alphabetical term or the variable term or the unknown terms, on the other side. So it will become 169, and it is the basic thing that whenever we move a term from left side to right hand side, or from right hand side to left hand side, or we simply say whenever we shift the term from one side to the other, it will change its sign. So as 25 was positive here, it will become negative when we shift it to the left hand side, and it will be equals to b square. Now when we will subtract it, it will be equals to 144. So 144 is equals to b square. So now we will do square root. So taking square root, it will be square root of 144, that is equals to b square. Now, if we don't know the value of a square root, what we can do? We will simply do the prime factorization of 144. That will be 2 times 72, 2 times 36, then 2 times 18, then 2 times 9 it will be. Then proceeding further, it will go 3 times, then it by 3 it will go 1 time. So now here we see that it forms a pair of 2 times 2 and 3. So we will just note down one number from the pair. So it becomes b square is equals to 2 into 2 into 3. That will be equals to 12. So by this we can say that QR will be equals to 12 centimeters. Hope you understand that. Now let us take another example when, okay, let's take another example in which the other side is missing. Like this, there is a right angle triangle, and as we can see in the previous one, the smaller value was given. Now let us consider some big values, and then we will try to solve them out. Like if it was 12 and if it was 13, then we will have to find out this side. And I'm taking the same example so that we can confirm that it will be the same value while we use the Pythagoras theorem. So now, if we are solving using the Pythagoras theorem, let me name it again as P, Q, and R. So according to the Pythagoras theorem, square of hypotenuse will be equal to square of perpendicular plus square of base. It doesn't matter if I'm writing base first or perpendicular at last. Okay, we can write it like this also. H square is equals to b square plus p square. Because it doesn't matter if I'm adding b to p or p to b. It will always yield the same result. Right. So now hypotenuse, which is equals to PR, square of PR will be equals to square of PQ plus square of QR. Then we will try to solve it again. PR, which is equals to 13. Square of 13 is equals to square of 12 plus square of QR. Now square of 13, that is equals to 169. Square of 12, that will be 144 plus QR square. We will shift this 144 to the left hand side, so it will become 169 minus 144, that is equals to QR square. Then when we will subtract it, it will be 25. So we can say that QR square is equals to 25, and we already solved it. The square root of 25, taking square root, taking square root, it will be equals to QR is equals to under root 25, that is equals to 5 centimeter. That is again similar to the previous one. Earlier we considered the 5 centimeter side and the result was 12. Now we consider 12 side and the result is 5 centimeters. So we can say that it is going to be the same thing. Okay, now let us take a real life example and understand why trigonometric theorem, oh sorry, why Pythagoras theorem can be useful in a real life. So let us consider that there is a wall and a ladder is placed just near the wall like this, and we have to find out that what will be the length of this ladder if we know the distance from which we are going to place this and the height of this wall. So let us consider that the height of the wall is 24 meters and the base of this, the base distance from the foot of the wall to the point where we are going to place the ladder is 7 meters. Then what will be the length of the ladder that would be required to climb on this wall? Okay, so now again in this triangle we find out that the angle B, let us say C, and let us say that it is E. So angle B is 90 degree, and in front of this will be the hypotenuse. The lower it will be considered as base. We are considering it as base because we are not referring to any angle right now. So we can say that this will be the base, and this will be the perpendicular. Now, in this case, again we are going to put the Pythagoras theorem. H square will be equals to square of perpendicular plus square of the base. We are going to find the length of the ladder, that is CA. So now we are going to write the Pythagoras theorem in the form of sides of this triangle. So hypotenuse, that is CA square, will be equals to perpendicular, that will be AB square, plus the base, that will be BC square. So now CA square, it is not known. AB, that is 24, we will square it. Then BC, which is 7, we will square it. Now CA square will be equals to square of 24. It would be better that if you learn the square up to 25, square then cube of the numbers up to 25 or up to 30, it would be better that you learn more and more. So square of 24, that will be 576, and then we will square of 7, that will be 49, and the square of CA will be equals to now 625. If we want to find the side length CA, so it will be square root taking square root on both sides. So it will be CA. Now square root of CA square will be CA, that we learned in the topic exponential power. And then CA will be equals to square root of 625. We can do it by the prime factorization method. And now CA will be equals to 25 meters. So if we learn the square then square roots, we just need to learn the squares, because if we know that the square of 25 is equals to 625, then it is completely logical that square root of 625 will be equals to 25. So by this we can say that CA will be equals to 25 meters. This is how we implement the Pythagoras theorem in right angle triangle in whatever shape it is. It can be in the shape like this, it can be in the shape like this also. It doesn't matter. We can use it in real life also. All that matters is the figure must be just a right angle triangle, and we can implement it to get the values. So just let's do a quick revision of whatever we studied. The Pythagoras theorem is simply square of hypotenuse, which is equals to square of perpendicular plus square of the base. And this Pythagoras theorem can be implemented only in the right angled triangle. And it can be implemented in real life also, like we did in the last example. It can be used in right angle triangle. It is the property, and in simple words, the side which is equals to side opposite to angle is equals to 90 degree, that is equals to hypotenuse, which we represented it as H. Then sides containing angle 90 degree, that are that any of the side can be considered as perpendicular, and any of the side can be considered as base. Perpendicular and base. All that matters is it must be a right angle triangle, nothing else. So that is all what we need to do in Pythagoras theorem. I will try to get you few of the questions after this slide so that you can prepare for the topic. Thank you. Okay, last but not the least, there is one more thing that you need to remember that if there is in a triangle, like three sides are given, but it is not disclosed that the given triangle is a right angle triangle or not. Let us say that the sides are given 10, 8, and 6, and it is not known that if it is going to be a right angle triangle or not. And what we can do is we can simply consider that the longer side of the triangle, if it is going to be a right angle triangle, then the longest side will always be the hypotenuse, which will be 10 centimeters. Then the other two sides, we can consider any of the side as 8 and any of the side as 6. Then what we are going to do, we will simply check that square of 10 will be equals to square of 8 added to square of 6. If this LHS is equals to the right hand side, then we can simply say that therefore this triangle, let us say that it is XYZ, therefore this triangle XYZ is a right triangle. Or we can simply check it. The square of 10, that will be 100, that is equals to square of 8, which is equals to 64, plus square of 6, that will be 36. And when we will add 64 and 36, it will be equals to 100. So we can say when LHS is equals to RHS. Therefore, this triangle is going to be a right angle triangle. Therefore, XYZ will be a right angle triangle. And now the time for the questions. So you can take the screenshot of the questions, or you can simply pause the video. Let me. So here are few questions, and these are really very easy to solve. Only the thing that you need to remember is just draw the right angle triangle first. Consider which side will be the hypotenuse, which side will be the other sides, and then you can easily find out the unknown sides or the unknown, or if it is asking that if the triangle is right angle triangle or not. So that is all. If you have any doubt, you can simply drop the message. Thank you.